Hey guys, my name's Nick from Test Me Tutoring, and we'll just be going over just some methods questions today. So, particularly trig functions instead of trigonometric, trig functions, as well as normal distribution. Now, I'll go into a bit more detail in a couple of minutes. I'll just wait, just because we've just started. I'll just give you guys about 30 seconds. Also, just for people to join if they are. Alrighty. So, I'll just get rid of all this stuff on the side, give them a bit more room. So, right. So yeah, my name's Nick or Nicholas Carle, and yeah, I'm a maths tutor. I've been for 6 years or so, and I'll just move this. That's right. For 6 years or so, and I graduated in 2013 from Strathmore. And I did both methods and specialist maths. So I then went on to RMIT and did Bachelor of Engineering and Bachelor of Science. And it was a great time. Was there for 6 years, and just thought I'd help out some Year 12s at the moment who are going through a pretty tough time, I'll be honest, with COVID and being locked at home, and just thought I'd do these streams to try and help out those people. So hope you guys enjoy it. Again, so I'm from Test Me Tutoring. If you want, I'll link in chat the website. If you want to head there, there's practice exams up every 2 weeks. I'm writing the practice exams. So I did my first one last fortnight. Had some really good responses from some students, and this stream is more going over some of the difficult concepts in that, as well as looking forward and the concepts that are coming up in the next SAC. So I've got a student that's doing methods at the moment. So looking at the concept of normal distribution in probability. So, and going over just a revision of that. So subscribe to us on Twitch, like us on Facebook. That'd be great. All right, so we can probably I think that's about it. We can probably get started. So trig functions. This question here, this one up here, intersections between two graphs. That was on the exam, and look, it wasn't poorly answered. I'll be honest, it was decently answered, but of all the questions, people had the most issue with this question. So I'd like to go through it in detail, but first I actually want to go through the whole concept of trig functions, because personally I think there's probably 3 or 4 question types that can be asked in both exam 1 and exam 2. And those questions, if you don't have a base knowledge of trig functions, you will not get, it's impossible to get them in the first exam and the second exam. The calculator doesn't help a whole lot. So we need to actually understand what's going on in trig functions, okay? So as I'm going through the stream, if you have any questions, if you have anything to say, just please shoot us a message in chat. I've got it up on the other screen, so I'll be watching that and answering any questions you guys have. Okay. So, trig functions. We're going to start with the unit circle. Now, usually I draw the circle, but I'm going to be doing it a few times today, so I'm just going to draw it as a shape. Cool. Okay, it changed color on me. All right. So this is a unit circle. Oh, geez. I'm just going to grab a line from up here. Okay. So the unit circle is divided up for trig into 3 bits in the middle of each basically sector around. We can draw a line like that, line like that, line like that. Now, if we were to measure the degrees of each line, this one here would be 30 degrees. This one up here would be 45 degrees. This one here would be 60 degrees, okay? And down here we've got one that's at 0, and then obviously one that's at 90. Now, that's degrees, and that's something we've learned all the way from year 7 to year 11. But in year 12, and year 11 a lot of time, we convert to radians, so what's called radians. Now, radians, I won't go too much into what they are, but they're another way of basically measuring an angle, okay? So instead of having 360 degrees all the way around a circle, so all the way around the circle going that way, starting at 0, a circle is 2 pi radians, okay? That means halfway around the circle is 1 pi radians, okay? So if 1 pi radians is all the way around, it's halfway around, sorry, pardon me, and 2 pi radians is all the way around, what would 1/4, so from here up to this 90 degrees bit be? It would be pi divided by 2, so pi on 2 radians, okay? 60 degrees, if pi is 180 degrees, yeah, what would 60 degrees be? It would be pi over 3. 45 degrees would be pi over 4. So that's 180 degrees divided by 4, and that gives us 45 degrees. And the last one, 30 degrees, would be pi over 6. Okay? Now, there is a formula to work this out. All right? That formula, we'll work it out now, because it's actually helpful to work out a proof to a formula. So if we've got our radians and we had our degrees, we had 60 degrees. And we know our answer is going to be pi over 3. Okay, that's going to be our answer. How do we get that? So what we need to do is we need to say, okay, if we multiply it by pi, and then we divide it by 180, what we get is we get 60 pi over 180. Then we cancel out the 60, so 1's left on top and 3's left on the bottom. Now that's pi over 3. So to convert any degrees, I'll write it over here, degrees, oh, that says degrees. Also, I haven't mentioned it. I mentioned in my last stream that I did on further maths, but in this stream, my writing's not fantastic. It is what it is, okay? I'm trying. Degrees to radians. So we get our degrees, so a theta in degree. We multiply it by pi on 180. And that gives us radians, theta in radians, okay? And if we reverse this, if we have thetas in radians, I'll write that at the bottom like it's meant to be. Theta in radians, we multiply it by 180 on pi, we get theta in degrees, okay? So I haven't got an actual multiple choice question. As we work through this, sorry, I forgot to mention, as we work through this, I'll be putting up multiple choice questions. And those multiple choice questions on Polev, I'll link them soon. And it will just be like some live interactive kind of things, okay? So if I have, let's say for example, if I had 2 pi over 3, okay? That's a radians. And we want to convert that into degrees, okay? So we get, that's this, I'll change color, get some color going. That's this formula here, okay? So 2 pi and 3, we're multiplying it by 180 over pi. So what we can do is that 3 becomes a 1 and that becomes a 60. We cancel by dividing both by 3. Hope that's okay with everyone. Yeah? The pi on top and the pi at the bottom, they can cancel. What we're left with is 2 times 60 all over 1. So we can ignore the over 1 and that gives us 120 degrees. Okay? Is that all cool with everyone? Everyone in chat? Hopefully that's all right. Just shoot us a message if they're not. Okay, let's keep moving. Again, we have our unit circle. So I'll keep drawing. You're going to see a few unit circles here, okay? So there's one and, oh, of course. No. Still getting used to this. There's one and there's the other. Yeah, and also these, all of these. All right, thanks. And all of these will be up on the Twitch channel after this. Okay. So let's keep moving. Yes. Okay. So we now know that we've got 3 here. We have our now I'm gonna from now on I'll be writing in radians. I hope that's okay with everyone. We need to learn our radians. So pi on 6, pi on 4, pi on 3, and that's at 0 degrees, and that's 0 radians, and that's at pi on 2. Okay. So now that we know our unit circle, we need to know this basic fact. Sine is our y-axis. I'm writing this big because it's important. Cos is our x-axis. All right. Sine is y. Now, you've got to get these mnemonic devices, and they're kind of like ways for you to remember. Sine, you can kind of spell sine with a y, can't you? So sine's the y-axis. All right. I don't know one for cos just yet. If anyone's got an idea, shoot it in the chat. So sine, the y-axis, cos, the x-axis. There are 3 values we need to remember, and that's all. 3 values. Now I've got a few ways of remembering these values, and they look like they're here, here, and here. The middle value is a half. The very first value is a half. The second value is a root 2 on 2, just cos lol. And the third value is root 3 on 2. Okay, I'll write them bigger here. 1/2, root 2 on 2, root 3 on 2. Now, there's many ways to remember these. There's a finger trick that you can do with your fingers that my student actually taught me this year that I've already forgotten. But I didn't learn it during high school. We had a different way of remembering it. But every teacher's got their own way. So the way I remember it is I write square root 1, square root 2, square root 3. All of them over 2. So square root 1, square root 2, square root 3. All of them over 2. And because square root 1 is 1, we can just ignore that. Square root. And that's going to be our 3 values. Okay? So I hope that made sense. We write both of those on the x-axis and the y-axis. Half, root 2 on 2, and root 3 on 2. Oh, there we go. All right. Half, root 2 on 2, root 3 on 2. Half, root 2 on 2, root 3 on 2. Okay? They are mirrored in the negative axis, but at the moment we're just sticking with positive first quadrant. Okay? So we can say, what is the coordinates of each of these points? So we've got basically a coordinate here, a coordinate here, and a coordinate here, right? What is the coordinate of pi on 6? The coordinate is on the x-axis. Remember I hope you guys remember this, x comma y. Okay? So our coordinate for the x-axis for pi on 6 is root 3 on 2. And the y-axis here is a half. Okay? Pi on 4. I'll change color. I'm going to probably run out of colors for this one. X-axis is root 2 on 2. And the y-axis is root 2 on 2 as well. And I'll scroll up a bit. Okay. And lastly, I'll just use blue again. Pi on 3. X-axis is a half. And y-axis is root 3 on 2. Alright? So they're actually pretty simple when you can remember it via the coordinates. And I mean, I'll do another method in a sec because as well, some people don't learn graphically. Some people like to remember tables. So I'll do it on tabular form in a sec. But for me, understanding how the unit circle works is the best way of actually remembering these values. Okay? So there are 3 coordinates. We've also got a coordinate down here at 0. I should have done that in green, sorry. Down at 0. What's the coordinate down here? If a unit circle is radius of 1, our coordinate is a 1, 0. It's 1 on the x-axis and 0 on the y-axis. Pi on 2's coordinate, which is the one up here, I'm going to reuse a color. Pi on 2 is 0 on the x-axis, 1. Okay, that's it. That's our first quadrant, okay? As soon as we can understand those values, we can figure out any other value on the unit circle. Okay, and when I say any other value, any other corresponding value on the unit circle. And we're going to get to that, okay? So, as a tabular form, I'm going to actually scoot this down a bit. Give me a sec, because this will help for the tabular form. Or copy and paste it, actually. There we go. So, as a table, nope, I actually need to choose a color. So, as a table, we have sine, cos, and then we have tan. Again, this is just a way to remember the exact same thing, okay? Just a different way, because everyone remembers things differently. Then we have 0, we have pi on 6, and I'll just put in brackets 30 degrees, just small, just so we remember. Pi on 4, I hope I don't run out of room, and that's 45 degrees. And we have pi on 3, that's 60 degrees. And we have also pi on 2. Oh, let's move it over a bit. We can cut off that. Oh, jeez. There we go. And pi on 2, which is 90 degrees. Okay. So, hope everyone understands this table, yeah? So we've got them and them. Now, what did we say before? What is sine, the x or y? Y, perfect. So, sine is our y. And cos is our x. Okay? So, we need to be looking at sine is our y values and cos is our x values. So, tan we'll come to in a sec. Sorry, I just had a blank down on tan. Tan we're going to come to in a sec. When we look at sine of 0, okay, so that's this one here and this one here. We look at this 0 coordinate, which is this one here. What is the y coordinate for 0? It's 0. Okay. So when we grab our calculator and make sure we've got it in radians, so this is my calculator. I didn't go over this. My calculator is a ClassPad. A lot of you guys might have the TI Inspire. They function the exact same. There's just a different layout, okay? Still a calculator. So if I go sine of 0, execute, the answer is 0, okay? The fact is we won't have our calculator for that first exam, and that's why we've got to know these values off by heart, or at least understand how to work them out. We then move up to sine of pi on 6. That's this one here. What is our y value for pi on 6? I'll give you a few more seconds. So our y value for pi on 6, that's this coordinate here. We're looking at the y coordinate, which is this one here. So that's a half. Okay? I'll move on to the next one. Pi on 4. The y coordinate of pi on 4 is that one there. And that's root 2 on 2. The y coordinate of the next one, pi on 3, is root 3 on 2. And lastly, the y coordinate of pi on 2 is 1. So I hope this is a bit of revision, you guys. If you're learning this for the first time, please let me know in chat. I'm going a bit fast because there's some other stuff we want to cover, and this we should know this, okay? So if you don't know it, please let me know in chat. You can send me a PM if you need, but I don't actually know if I can see them in the chat room. But anyway, I'll keep moving. So now we're looking at cos. Now remember, cos is the x axis. Okay, so we're looking at all x coordinates now. I'll do this in green. What is the x value for 0? Perfect, 1. What is the x value for pi on 6? So remember, we look at our pi on 6 coordinate, which is that one there. It's perfect, good, root 3 on 2. And I'll keep moving now. Pi on 4, root 2 on 2. Pi on 3, a half. And pi on 2 is 0. So I hope that's all right for everyone. Exactly right. Spot on. It's the opposite for sine. So anytime as we're moving across in the x-axis, as we're moving up in the sine, we're moving backwards in the x. So we're up in the y, we're going backwards in the x. All right. So, and that's why you only really need to remember the three values, which is root 3, half, root 2 on 2, root 3 on 2. Okay. And 1 and 0 as well. Those are values, but hopefully with the unit circle and coordinates, you know your 1s and 0s. Okay. The last thing is tan. Now, tan is a bit difficult. It's a bit of a different beast. Knowing the unit circle is imperative to work out sine and cos, and to figuring out tan, unfortunately. So tan of theta is equal to sine of theta over cos of theta, right? So once we know our sine and cos values, it gets pretty easy, because as long as we know our fraction maths, it's fine. So let's say, what is tan of 0? That is equal to 0 divided by 1, which is 0. Okay? So tan is 0. Tan of 0 is 0. Now we move on to tan of pi on 6. Bit harder. You guys give it a go and see. Tell me what you think. I'll give you guys 30 seconds or so to tell me what you reckon. And if I don't hear anything in 30 seconds, I'll just give it a go, all right? All right, all good. So tan of pi on 6, the sine value of pi on 6 is here. So that's a half. And we're dividing that by the cos value of pi on 6, which is root 3 on 2. Okay? Now with fractions, keep, swap, flip. Some stuff we learned in year 8 are coming back. Okay? We cancel out the 2's and we're left with 1 on root 3. Now, I'll quickly go through rationalizing. Hopefully you guys know rationalizing. If I have 1 over root 3, we can't have a square root on the bottom, so we multiply by root 3 over root 3. Root 3 times root 3 is 3. I know that sounds confusing when I say it fast, but our answer is root 3 divided by 3. Okay? Again, it's a bit confusing. Let me know in chat if you need me to go over that again. Hopefully it's okay. But our answer is root 3 over 3. Okay? Now, if we were to do that to the other values, again, that gives us 1. That gives us square root 3. And that is undefined. Now, the reason that's undefined, tan of pi on 2 is 1 divided by 0. Anything divided by 0, you can't do. It's undefined. I'll show you on the calculator. Tan of pi on 2, tan of... there's a shortcut for pi, I think. Anyway, it's there. Pi over 2. Undefined. Okay? Hopefully that makes sense. So, I think I've got a multiple choice question for these. I think. Let's have a look. I think I've been multiple choice. Yeah. So. No, I haven't just yet. Have I? Yeah, I have. Okay. So, I'll just quickly explain one more thing and then we should be good to go with that multiple choice. Just because I think I've still got it copy and pasted. I'm going to keep bringing down this unit circle, okay? I hope everyone's all right with that. Symmetry. Now, if we look at values on the other side of the unit circle, okay? So if we were to extend these lines here, extend this line here, and extend this line here, the y values on this side of the unit circle, where I'm drawing now, will be identical to the y values on the first quadrant side of the unit circle, okay? So, the y values for this value up here, and I'll get to the radians in a sec, will be root 3 on 2 will be the y value, won't it? The second one, the y value will be root 2 on 2. See how we've just kept the exact same height on the y-axis? So all we're doing is we're just copying over the y values. And that's a half. Okay? X values we'll come to in a sec. But at the moment, that's the y values. So, and I'm going to draw off unit circles here. Actually, just paste this one and rub out some stuff. It's in the essence of time. So I hope I'm not going too fast for everyone. If you guys know this stuff, I think it's a really good refresher, okay? So let's just erase all this. All right. That'll do. All right, cool. So, and I've oddly drawn this probably more accurately than I usually do, which is good, probably because I've used the straight lines. So if we think about the unit circle cut into quadrants, or cut into like pieces of pie, if you want. If we look at, let's say that pi on 3 value, that's 60 degrees, right? If I cut another 60 degrees off that, that's gonna give us up here. Now, so this value up here is 2 pi on 3. And this value here is 3 pi on 3, or if we cancel out those 3's, pi, which we knew, right? Then we go down here, another 60 degrees, and that's 4 pi on 3. And another 60 degrees here, 5 pi on 3. So what we can do is we can count up by pi on 3's as we move around. Simple? So that's the blue ones, that's pi on 3. I'll change that to blue so we can follow that. This one's gonna get colorful. I hope everyone's all right with that. Okay. Now, the next one is our pi on 4's. And I'll just make that one red. Pi on 4. So the 0 radian is 6 pi on 3. Perfect. Exact. Oh, spot on. Good point. I didn't finish it. So that's 6 pi on 3. Or, if we simplify that, if we divide both of them by 3, that gives us 2 pi. And that's one whole way around the circle. That's a whole revolution. Spot on. Okay? Or it's 0. So it depends where we are around the circle to if it's 0 or 2 pi. But again, we'll get to that in a bit. But good work. Yes. So that's pi on 4, which is the red. Oh, I should not do this in red. There's already red, isn't there? Do it in green. So that's pi on 4. Two pi on 4. Straight up. That's 2 pi on 4. Or pi on 2. We go over here. That's 3 pi on 4. 4 pi on 4. Down here, that's 5 pi on 4. 6 pi on 4. Or 3 pi on 2. And that's 7 pi on 4. And this one over here is 8 pi on 4. So I hope the color coordination helped with that one. Yeah, or that's also equal to 2 pi, obviously. Okay. I'm definitely gonna draw another unit circle for pi on 6. It gets a few more lines. Shape, circle. All right. So pi on 6, I'll do this in white. Pi on 6, that's our 30 degrees. Second 30 degrees, if we add another 30 degrees or another pi on 6, that gives us 2 pi on 6. Or pi on 3. See how we've gone from 30 degrees to 60 degrees? All we're doing is adding 30 degrees, if you want to stay in degrees, or adding pi's on 6's. So that's 3 pi on 6. 4 pi on 6. 5 pi on... Oh, no, that's not in the center. It's meant to be a bit further up. 5 pi on 6, and then 6 pi on 6, okay? Or 1 pi. That one up there is 2 pi on 3. And we can basically keep adding pi's on 6s as we move around the unit circle, if that makes sense. So pi on 6, 2 pi on 6, 3, 4, 5, 6 as we move around, okay? Now, I know that's a lot of information to take in, and I hope everyone's all right with that. So, I'll let it sink in for a sec. Great, good to hear. So, if we look at this unit circle up here, we've still got 3 values, and they're going to be the exact same 3 values on this side, but negative. Oh, that got small. That's a negative, okay? So, when we look at, all we need to do is basically fill in these coordinates. And last one there. Okay? So the green one, negative root 3 on 2. The blue one, or dark blue, sorry, negative root 2 on 2. Oh, that got a bit tight. I drew the brackets before I drew it. That's very rookie. And this one, a half. Negative half. Okay? So, all we're doing is looking at the coordinates of where those things are positioned. Okay? So, in radians, if we just look at the other 2 unit circles we've drawn, this one's 2 pi on 3. This one's 3 pi on 4. This one's 5 pi on 6. That got very tight very quickly. 5 pi on 6. Yeah? Great. So, hope that's okay. Now, there is a bit of a cheat method. And you guessed it, I'm going to draw one more unit circle. I've got notes on my other screen, and this is way more unit circles than I intended to draw, but I think it's necessary. So, let's move you. Oh, of course. That's not straight enough. Oh, I'm going to try one more. If it doesn't work, then we're sticking with it, okay? Oh, spot on. All right. And the thing to remember is cast. Okay? Like all students teach chemistry, is one I've heard. I've heard some more M-rated ones that I won't repeat on stream. But just remember some way of remembering ASTC, okay? Basically, this is saying all values are positive. Only sine values are positive. I don't know why I rewrote S. Only sine values are positive. Only tan values are positive. And only cos values are positive. Okay? And when you think about it, it makes sense. Okay? Sine is what? X or Y? I know I asked it before. But sine is our Y coordinates. Okay? So, sine is only going to be up the top, positive. Okay? Cos is our X values. So it's only going to be on the right side of our screen, of the unit circle, positive. Because these are the positive X values. Tan, because you're dividing. A negative and a negative divided by each other gives you a positive. And that explains why tan's positive here and here. Alright? Again, it can be confusing. I hope it's been okay. I'm going to give you one example, and then we're going to go to a multiple choice question and see how you go, okay? So, if I said, what was the cos value? Oh, yeah, let's see a cos value of 7 pi over 4. Okay? I'm going to explain how I work it out in my head, what my head processes. Where is 7 pi on 4 on the unit circle? So, we know that 7 pi on 4 is here on the unit circle, right? If we're counting up by pi's on 4s, we go 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, and then 7 pi on 4. So it's in that fourth quadrant. We know that pi on 4, the cos value of that is root 2 on 2. Okay, so that's that center point here. On the unit circle, we just draw straight down, and that gives us the cos value. So cos of 7 pi on 4 equals root 2 over 2. I hope that makes sense, okay? So these first quadrant coordinates, and I know this looks like an absolute mess now with 4 unit circles drawn. I shouldn't have drawn that there. I just wanted to give you guys the opportunity to look at the unit circles. So cos 7 pi on 4 is equal to root 2 over 2, positive root 2 and 2. All right, we're going to go now to a question on Pollev because I need to see if you guys can have understood this, okay? So I'll link it in chat, the Pollev. Where is it? Hang on a sec, hold up. Here's our link. So if you hop onto that link there, I'm going to present now. It's what is cos 5 pi on 6. Now I might be able to do this for you guys. Here we go. Just so you guys can have the unit circle up. Hopefully it's not too small on your screen. If it is, just shoot me a message in chat. But basically we're trying to work out what the cos value is for 5 pi on 6. Now I know if you guys can do this in your head, that's all the better. But if you can't, feel free to use the unit circle I've got on the right. Okay. So sorry, I'll just show this. And I'll give it a few more seconds. So I've got one response. All right, let's have a look. Let's have a look at our responses. Okay, not quite. Okay, so I'll go over how we get this value. So remember, the first thing we do is we say, where is 5 pi on 6 on the unit circle? Now 5 pi on 6 on the unit circle, I'm going to redraw a whole unit. Oh no, it's okay. I'll still use this one up here. 5 pi on 6 on the unit circle is right there. That's that value up there. Okay. So the point on the unit circle in the first quadrant, so I've forgotten the word for it. How did I already forget the word? I just said it like 10 seconds ago. Anyway, the respective point in the first quadrant is this pi on 6 value here. Okay, no worries. So we look at this first quadrant and we see this pi on 6. So see how it's joined via that? The pi on 6 value in the first quadrant is root 3 on 2. Okay. We then can look at the positive unit circle and we say in the second quadrant only the sine values are positive, so cos is going to be negative, so it's going to be negative root 3 on 2. Okay, the other way to think about it, and this is I don't like that way because it gets very convoluted very quickly, is, and I'll draw, okay, I'm going to draw one more, but it's going to be a clean unit circle down here. Okay, it's just fresh. It's in green. It's going to be in green. No, we can change it. It's red again. Okay. And that's, it didn't work. Okay. All right, we know, let's say we know where 5 pi on 6 is, because I hope we do by now. 5 pi on 6 is over here. Okay. So if we've got the 3 points here, we know that there's 3 points on the x-axis, and we know them, that they're going to be negative half, negative root 2 on 2, and negative root 3 on 2. We know cos is our x values. Okay? Cos is our x values, so it's the x coordinate of the point that's furthest across, and that gives us negative root 3 on 2. So by thinking like this is how we can get a lot better at doing these things in our heads. Now I know this is a lot of information, and if you don't know the unit circle, if you didn't know it coming into this, I can understand this might be coming a lot of information very quickly, but feel free, once this is over, the recording is going to be up at the Twitch stream, and I'll also be putting this up on your YouTube, and I encourage you to just go back and rewatch this and just get familiar with the unit circle, because it is important. I also encourage highly that every single day, and I know this is going to be a big one, every single day draw the unit circle. Okay? Anytime you do methods, just draw the unit circle somewhere. I do this with my students, my method students. I say every single time, no matter what we're doing in class for the tutoring session, very start of it, 5 minutes, in the end it takes like 1 minute to do once you get really fast at it, but 5 minutes at the start, just draw that unit circle. Okay, get familiar with it, understand it, because it will help you solve every single question related to trig functions. You cannot do it without it. Okay, the calculator is only so helpful, but in the first exam you don't have that calculator. Okay, so are there any questions from anyone that's in the chat? I feel free to message in the chat if you need, but I'm going to keep moving. Okay, so we've spent a fair bit of time actually on that. So, have I got another question for that? I think I might. Hold up. Let's have a look. Yeah, okay. Here's one more question for you guys. What is sine of 3 pi and 2? So go back to that Polev. And again, I can bring up these if it's helpful. What is sine of 3 pi and 2? And I'll just hide responses. And yeah, please interact with these. This is helpful for me to know you guys are understanding what I'm saying, as well as just, yeah, for you to actually prove that you have understood it. Okay. So we've got to be asking ourselves, where is 3 pi on 2? Okay. And helpful to be, where is pi on 2? And then we're moving that far around the unit circle each time. All right, I think I haven't got any responses just yet, so we'll just give you one more sec. Oh, perfect, good. Let's see. Come on, guys. Yay, great work. Okay, so why is it -1? Where's pi on 2? Pi on 2 is up here, this very top value, up there. Okay, I'll just get rid of this other arrow because that could confuse people. Pi on 2, then 2 pi on 2 is over here, because we're moving by 90 degrees each time. 3 pi on 2 is going to be right down the bottom here. Now, we know that the y coordinate, because it's sine, so the y coordinate is going to be -1. Right? Because we're right on the edge of the unit circle, and the unit circle has a radius of 1. Alrighty? And lastly, now this one's a bit harder. It's our tan values. Oh, sorry. Again, a bit harder. I'll give you guys a tiny bit of extra time on this one. Yeah, this one could get a bit complex, but I suggest you just think 8 pi on 3. Which of the first quadrant values is this going to be? Okay, think about where on the graph 8 pi on 3 is. So remember, we've got 1 pi on 3. I'll just go down here and I'll just get rid of this. So remember, we're counting by pi's on 3, so that's every 60 degrees. You got 1 pi on 3, 2 pi on 3, 3 pi on 3, 4 pi on 3, 5 pi on 3, and so on all the way around. So where are we going to end up? And remember, we can do 2 laps around the unit circle if we need. And remember, so if it's this I'll just give you a hint. 8 pi on 3 is up here. What is the corresponding, there's the word that I forgot before. What's the corresponding value in the first quadrant? If we draw our way across. And then we've got to remember what is positive, negative in different quadrants. Remember that ASTC. Oh, great, we've got a response. Great. How are we looking? Great, perfect. So, again, I'll reiterate this. So we're going 1 pi on 3, 1 pi on 3, 2 pi on 3, 3 pi on 3, 4, 5, 6, 7 pi on 3 up here, 8 pi on 3. That's this value here. Okay, so we know we're up here. The corresponding value, if we draw across to the first quadrant, is pi on 3. If we remember from our table, pi on 3 for tan is square root of 3. So we know square root of 3 is going to be our value. And now we just need to think, is it positive or negative? So square root 3 is our value. It's tan of 8 pi on 3. Is it positive or negative? It's in the second quadrant. Only sine is positive in the second quadrant. So it is negative square root of 3. All right. I hope that's okay, guys. Yeah, again, shoot us a message in chat if you have an issue with it, but hopefully we'll keep going because you got that right, so that's great. We have our last bit. Now, okay, this could get, that one was tricky. Yeah, it was. 10 is tricky. So, we've got now, if we have an angle, what is the value? But a lot of the questions are, what if we have a value? What angles are they? So this one's going to get a bit convoluted, and I hope I make sense as we move through this. Okay. So if I draw, guess what? Another unit circle. I really should just have like a shape made for unit circle with these axes. Oh, this one. Okay. That's relatively straight. Now, if I grab this, let's say square root of 3 on 2, which is that n value, because remember we've got 3 values. This n value. If I say what values around the unit, what angles around the unit circle have a cos of root 3 on 2? Okay. So when a cos inverse of root 3 on 2. So cos of an angle, the answer is root 3 on 2. What is that angle? And that's what we've got to ask ourselves. So on the unit circle, that looks like this. Pi on 6 is one of those values. But we can also draw it down here. And that's going to be 7. That's not going to be 7 pi on 6. It's going to be 11 pi on 6. If we count all the way around like this, pi on 6, 2 pi on 6, 3 pi on 6, 4, 5, 6, 7, 8, 9, 10, 11 pi on 6 is going to be the value over here. That's going to be our root 3 over 2 value. So we can say cos inverse of square root 3 over 2 is equal to pi on 6, 11 pi on 6. But we don't stop there. We can keep moving around the unit circle. So if this is 11 pi on 6, that's 12, 13 pi on 6. And we keep going all the way around, all the way around. I'll give you guys a hint. That's going to be 23 pi on 6. Okay? And just keeps going all the way around. And what you can do is you can form a pattern here. So it's going 1 pi over 6 plus 10 pi on 6. And that gives us 11 pi on 6. Plus 2 pi on 6. 13 pi on 6. And then we plus another 10 pi on 6. Right? Hope that's okay. And that's how we figure out our inverse values. Now, a lot of the time our inverse values will basically say, okay, I want to restrict this. I don't want to be going all the way from 0 to infinity. I want to only get values from between 0 and 2 pi. And you'll get stuff that looks like this. And you'll say, okay, x is an element of, it's theta, sorry, not x. Theta is between 0 and 2 pi. So we basically look at these values here and we say, okay, which of these values is below 2 pi? And that is just this one and this one. Because remember, 2 pi is 12 pi over 6. So all of these ones, they're above 2 pi. Okay? So hopefully that makes a bit of sense. Yeah, hopefully it made a bit of sense. So we'll give it an example, okay? And we've got a multiple choice question coming up as well for this, but I'll basically go, what is cos, I'll go sine, just, mix it up a bit. Sine theta equals, let's say root 3 on 2 as well. I'll make it negative, okay? I just need to make sure this isn't the multi-choice question. Yeah, cool, it's 10. So sine theta equals negative root 3 on 2. So basically we say for x, and let's say it's from 0 to 2 pi. Yeah? We go sine inverse of negative root 3 on 2 equals theta. Now, this is the algebra bit of it. We need to understand how do we get the algebra bit, but that's not the hard part of the question. This part now coming up is the hard part of the question, okay? Where on the unit circle will the y value, because remember sine is y, will the y value be negative root 3 on 2? Okay? What angles give you negative root 3 on 2 as the y value? Okay? So, I'm just going to copy and paste this unit circle so I'm not... Oh, didn't know it could do that. That could be helpful. Let's move this down here. Let's remove this. So I'll go through it in a sec, but I just want you guys just to have a think where you would start. Okay. Okay. So a negative root 3 on 2, we know sine is y. Remember? We can write it as like sine, maybe. So sine is our y-axis. So we're looking at negative root 3 on 2 on our y-axis. Where are these angles that have this value? It's going to be this one down here. It's going to be this one down here. Now, if we knew our unit circle, and hopefully we do, we'll know what these angles are. Because we have corresponding angles up there. So what's this angle up here? It's the very highest one in the first quadrant. It's pi over 3. Okay? So that is going to be our corresponding angle. Okay? But pi on 3's value is positive root 3 on 2, so we don't want it. But we can count around with it. So we go pi on 3. That's 1 pi on 3. This is going to be 2 pi on 3. That's going to be 3 pi on 3. This one down here is going to be 4 pi over 3. This one here is going to be 5 pi over 3. So our y where the y is equal to negative root 3 on 2, our theta is 4 pi on 3 and 5 pi on 3. Okay, I hope that makes sense for people. So another way of thinking about it is, where is sine equal to just normal root 3 on 2 in the first quadrant? If we look at our table, all the way back up here, sine is equal to root 3 on 2 at pi on 3 degrees. Okay? Oh my gosh, I've gone pretty far down, huh? So, theta equals pi on 3 in the first quadrant. But we're not looking for positive root 3 on 2, we're looking for negative root 3 on 2. And where is sine negative? It's negative in the bottom 2 quadrants. So that's going to be here and here. Okay? And that's 4 pi on 3 and 5 pi on 3. Now, again, whole lot of information there. Please, in chat, if you have questions, let me know. But I hope that's okay. Admittedly, this multiple choice question, I just saw it then when I flicked over. It's going to be hard because it's tan. I probably should have done a sine or a cos one. Please give it a go. Don't have an issue if it's a bit more difficult. So this one's not looking for, oh gosh, what happened? Don't know what's happening here, but okay. There we go. We'll just leave that up there. Okay. So, how many solutions are there going to be? It's not exactly what I was asking before, but how many solutions are there going to be? So how many different angles will there be where tan is equal to negative root 3 over 3? And that is from, and this is an important part, it's from negative pi all the way around to 2 pi. Okay? So negative pi starts here, and then go all the way around twice. So we go all the way around twice to 2 pi. All right. All right, we got a response. This one's a very hard question, guys. Oh, great work. So you got 3. Okay, so how and why? Because I'm sure if we've got other people in the chat that didn't respond, why is it 3? So we are going to draw another unit circle. Yay. Oh. So first we need to understand our domain. Our domain is from negative pi, which is over here, all the way. I'm going to draw this arrow all the way around. So that's to 0 now. We're at 0. Going to keep going all the way around. That's to 1 pi. Keep going all the way around. That's to 2 pi. So that's our domain's going all the way around. Okay? Hope that makes sense. We have now got, where is tan in the first quadrant? Where is tan equal to positive root 3 on 3? Okay, where is it? Equal to positive root 3 on 3. So we go back up to our table, all the way up here. Tan is equal to root 3 on 3 at pi on 6. Okay, that's this value here. Pi on 6. Okay? So we know that on our unit circle, wherever it is, here it is, pi on 6 is going to be a positive root 3 on 3. But we're wanting negative. So according to our ASTC, where is it going to be? It's not going to be in this quadrant because that's positive. It's not going to be in this quadrant because that's positive. So it's going to be in the second quadrant here, the sine quadrant and the cos quadrant. So if I just remove that and that. So those values are going to be this one here, this one here. So all we need to ask ourselves is, working it around the domain, how many times do we hit those 2 points? Those 2 coordinates, the ones in light blue. Oh, I need to rub that out. The ones in light blue, how many times do we hit them as we're going around? So we're going this way here. We hit it once. Keep going around. We hit it twice. Keep going around. We hit it a 3rd time here. And that's why there are 3 solutions, okay? Hope that makes sense. All right. So the last thing I want to do now, this is going to be a bit of a, I'm going to move a bit more quickly through this question, and it's the one that was on the methods exam. So every fortnight, as I said earlier, there is a methods exam that I put up on testmetutoring.com.au, and basically it's just to allow you guys to really refresh yourselves with some of the VCAR style questions. This was a question I put up. Again, it wasn't answered poorly, but it still wasn't answered as well as all the other questions, okay? So I want to go through this question. Now, it's going to have a lot of assumed knowledge in this. I don't have time to go through all the algebra required, okay? If you want me to, if you have a specific question, please let, oh, pardon me. If you have a specific question, please let me know. But if you don't, please just try and follow along. As I said, the videos will be up later, okay? So if you want to have a look again slower. So the question states, finding the intersections between f of x equals a half tan of 3x and g of x equals sine of 3x. Now the domain of x is between negative pi and pi. Now again, this is for students that did the, I mean, you can do it if you didn't do the exam, but this is going to be a work through of how we do this question, okay? And my thinking along the way. So, as soon as it says intersections, we know that we're going to equate the two graphs. So we're going to have a half tan 3x, and we're going to equate it to sine of 3x, okay? We know that tan of theta is equal to sine theta over cos theta, right? I went through that earlier. So what we've got here is a half multiplied by sine theta, or sine 3x, over cos 3x. And we're equaling sine 3x. Okay? Now this is the algebra bit. We multiply both sides by cos 3x. And by 2 if you want to get rid of the 2 on that side. So we have sine 3x. Where am I? Yes, sine 3x equals cos 3x sine 3x. And there's a 2 at the front. Okay? Now, what next? What we can do is we want to bring it all on one side. So we have sine 3x minus 2 cos 3x. Again, this is the algebra coming in. Sine 3x. And equals 0, because we've got nothing left on the right. What's common between these two? Sine 3x is common. So we have sine 3x taken out as a common factor. And we're left with 1, I hope you guys know your factorization, minus 2 cos of 3x. And that is equal to 0. So what we've got here is we've got two terms, don't we? There's multiplication in between them, and they're equaling to 0. Now, quadratics, it's a while ago that you guys probably have done quadratics, but I hope you guys remember what's called the Null Factor Law. So, Null Factor Law. Basically, when we've got two things that equal 0 multiplied together, we can have, it means that either one is going to be equal to 0, because 0 times anything is 0. I won't go over the Null Factor Law, but it is what it is. So we say sine 3x is equal to 0. And we say 1 minus 2 cos of 3x is equal to 0. Okay? And now we can think of these two things as individual trig functions that we can solve. It's now exactly what we did before. And we've just got to remember our domain. X is an element of negative pi to pi. Alright? So, 3x is equal to sine inverse of 0. We've just brought sine to the other side. I'll just do this one for start, and then I'll move to the cos one in a sec. So, 3x now is equal to, what is sine inverse of 0? We want to basically say, where does sine equal 0? Okay? What angles does sine equal 0? So, we look at our unit circle. Now, this is, pretending this is an exam question, this is how I'd do it, because we don't have access to something that can draw for us. Basically, I'm just going to draw a small unit circle here. It looks like that. Just draw it like that. And I'll say sine is equal to 0. So that is on the axis. So that's going to be here. And here, right? The y value is 0 there and there. So we know that that's 0. That's pi. That's 2 pi. 3 pi. 4 pi. Yada yada. And I'm just for the sake of speed here, I'm just going to make it from 0 to pi. Okay? I've changed the question. Just changing it. Okay? So 0, 1 pi, 2 pi, 3 pi. Okay? They are where sine is equal to 0. So that's 0, comma, pi, comma, 2 pi, comma, 3 pi. Okay? Now if this was if it was going back to negative pi, we'd be going in the other direction as well. Negative pi, negative 2 pi, negative 3 pi, etc., etc. Hopefully that's all right for people. We then want x by itself, so we divide this by 3. That means we've got to divide all of these things by 3. And that changes things. So x is equal to 0, pi over 3, 2 pi over 3, and 3 pi over 3. Which cancels out, which leaves us with pi. So we have 1 value, 2 values, 3 values, 4 values for this side. Very confusing one, that one. I hope it was okay. That's the sine side. We do literally the same thing for the cos side. So hopefully if you didn't understand the sine, hopefully you can follow along with the cos. We want to get cos 3x by itself. So we minus 1 from both sides. Yeah, I won't go through this, but negative 2 cos 3x equals negative 1. Divide both sides by negative 2. Cos 3x equals a half. Okay? Then say the cos inverse of both sides, and that leaves us with 3x equals cos inverse of a half. Right? We now ask ourselves, where does cos equal a half? Okay? So if we were to scroll up, or if anyone can say in chat, in the first quadrant, where does cos equal a half? I'm just going to grab some water while you guys type. Yeah, perfect. Yep, spot on. Pi on 3. Okay. Thank you, Coughing Bean. So, let's have a look. Pi on 3. So that's the one up. Oh, sorry. That's the one up here. Oh, okay. Of course it changes to red. So that's pi on 3. Now, where is cos positive? Which quadrants? If we've got 1, 2, 3, and 4. Those are the 4 quadrants. Which 2 quadrants is cos positive in? Yeah, the right one. So 1 and 4. Okay. So we look at here and we say, okay, A and C. Oh, yes, right. ASTC. Good call. Okay. So that's these 2 ones here. So we know these are going to be our values that we need to work towards. So we've got pi on 3, 2 pi on 3, 3 pi on 3, 4 pi on 3. This one's going to be 5 pi on 3. Okay. We look at our domain. Now, this 3x changes things, so we need to go give us a few extra numbers. So we start here and we go, okay, pi on 3, 5 pi on 3. We definitely know that those two are in. Pi on 3, 5 pi on 3. Okay. We then keep going and we go 5 pi on 6 pi on 3, 7 pi on 3. Keep going. This comes to 7, 8, 9, 10, 11 pi on 3. Okay. Now, if we then divide them all by 3, because that's what we've got to do, x is equal to pi over 9, because pi over 3 over 9 is pi over 3 divided by 3 is pi over 9. 5 pi over 9. 7 pi over 9. Now, 11 pi over 9. What's wrong with 11 pi over 9? Why don't we want 11 pi over 9? Not quite. No, 12 pi over 9 is not it. Oh, is 1 2 pi over 9? Okay, why do you say 2 pi over 9? No, so 2 pi over 9 is over here, and the cos values over here are negative, so we don't want those. We only want pi over 9, 5 pi over 9, 7 pi over 9, and 11 pi over 9, okay? The reason we don't want 11 pi over 9 is it's outside of our domain. Our domain stops at 9 pi over 9, or 1 pi. So we don't want that, okay? So, to tie up all of this. Oh geez, we've gone through a lot here. 0, pi over 3, 2 pi over 3, pi, then pi over 9, 5 pi over 9, and 7 pi over 9. It is an extremely difficult question. It's one that's worth 4 marks on exam 1. It is I won't say it's common, but things like this are really, you're going to have a question around trig functions and equating trig functions or solving trig functions. You're going to need to know how to do these. Okay, so again, the video will be up at Twitch. I'm going to keep having to press on. I think I have a lot of questions. Can I miss it? Yeah, of course you can. I'll stay after the stream as well, and we can go through this in a bit more detail. But we're going to keep having to push forward for normal distribution, just in terms of time. Yeah, I don't really have a time schedule, but if you got any, I can answer 1 or 2 questions now if you need. Okay, great. After the stream would be good. All right. Okay. So. Normal distribution, I'm going to need my calculator. So let's go here. So I just want to let's take a minute break. Please get up and stretch. It's very difficult to study and to keep concentrated for this long. Yeah, I'm impressed that some people have stayed for this long without, you might have other tabs going, but yeah, get up and have a stretch. Alrighty, so I hope everyone had a bit of drink of water and a bit of a stretch. Alright, let's keep going. We're doing some normal distribution now. Now, this was not on the exam, on the methods exam that I went through, but this was on my methods student, at least the one I'm tutoring at the moment. He is doing normal distribution now, and there's going to be a SAT coming up in the next couple of weeks. So I thought, rather than go over some other stuff that we've done, I'll help you guys out and go through some normal distribution, okay? Now, what is normal distribution? It is just a way that we can represent a whole lot of data, or a spread of data, okay? Now, it's done via the bell curve. Now, I'm sure you guys being in year 12 have heard, oh, that's a bad bell curve. I'm sure you guys have heard a lot about a bell curve in terms of ATARs and study scores and things like that. But basically, we're saying that the most amount of people are going to be on the mean, okay? We then have these lines on either side. And these lines represent percentages, okay? And yes, it is how they do a lot of exam marks and things like that, okay? These percentages are mu plus 1 standard deviation, okay? Mu plus 2 standard deviations. And this one over here is mu plus 3 standard deviations. Oh, no, that's the wrong symbol. That's not meant to be omega. It's meant to be mu. Mu plus 3 standard deviations. Now on this side, pretty similar. Mu minus 1, mu minus 2, and mu minus 3. Okay. So, again, any questions? Shoot them in chat, please. Because yeah, it'd be good to get some conversations going around this because it's some difficult stuff. So we have these percentages in here. So basically, if we take mu, our average, and we say everyone who got less than the average, what percentage of people? 50%. Okay, so we know that 50% of people are on that side and 50% of the people are on this side. Now I've put arrows at the end. It actually should be arrows like that because it goes all the way. Okay. Have I done that? 1, 2, 3. Yeah, 3. Cool. So we then basically restrict inside the, via standard deviations. So from mu to mu plus 1 is 34% of people are between mu and mu plus 1. 34% are on this side. Okay. The next one, 13.5. I'm not going to, it's percent, but I didn't have room. Okay. That's 13.5 as well. This is 2.35. And from here upwards, oh, I don't know why I drew that through it, but from here upwards is 0.15%. And from here down is also 0.15%. Okay? Okay. So, these are basically the figures that we need to remember. Okay? Now, admittedly, these ones are done in, you probably glossed over. In further math, that's where it stopped. But in methods, we get a little more detailed with how we figure these out. But it all requires a calculator, okay? So, just to, I don't know, flex the brain a bit, let's give one of these questions a go. So we've got mu, let's say mu is equal to 300 kicks. And it's the average number of kicks in an AFL game. Hope everyone understands AFL. But you kick it. All right, and standard deviation is 30. Okay? So the question might be, what percentage of games, games, no, no, not go Tigers, of AFL, assuming they're normally distributed, will have between 240 and 330 kicks. Okay. Now, I do have here, I don't know if I think I put it further down here, just because my drawing is not fantastic. I did put it here. No. Sorry. No, okay, it just deletes everything now. There we go. Here is a better bell curve. But these numbers under here obviously are not right for this question, but we've got the exact same. We've got mu standard deviation 1, 2, 3, etc. So just give it a go. Type in chat. I'll give you guys 30 seconds or so, and then I'll go through how we get the answer. Alrighty, so how do we get this answer? So let's have a look. Our mu, or our average, is going to be, we can write that here, not quite with 68, not quite. So 300 is our average. 330 is going to be up one. 270 is down, and 240 is down here, okay? So what we've got to do is we have to, they're our boundary conditions. Oh, here, all the way up to there. And we just add up the percentages in the middle. So that's 34 plus 34 plus 13.5, which gives us 81.5%. Okay? So again, a bit more of a simple, why did that pop up? Yeah, great. So if we have a look at Polev, everyone, I'll link the Polev again. Just for anyone who's new to the chat. Let's have a look at the next question. Oh, I had an extra question. It's all right. So, oh, it doesn't like it when I, Oh, no. Sorry. There you go. Sorry, that was all over the shop. So, the time taken in seconds for the time it takes to drive around a racetrack, so that's a bit poorly worded, is normally distributed with a mean of 61 and a standard deviation of 8. Okay? What's the range of times that encompass 47.5% of those values? Okay? So I'll bring up the, I'll just move this over here. Just to, if you guys want to work on it. So we've got to look at what different percentages on the bell curve can add up to that 47.5%. Alrighty, so we've got one response. Let's have a look. Spot on, great work. So again, let's have a look at y. So 47.5%, mu is 61 and standard deviation is 8. If all these values are wrong, if we have 61 here, that means that 47.5% is a 34 plus a 13.5. Okay, so it's going to be a 34 plus a 13.5. So it's either going to be 61 to all the way up to 2 standard deviations. So it's either going to be 61, 69, and 77, or 61, 53, and 45. So it's either going to be 45 to 61 or 61 to 77. Okay? Hope that made sense. Now is where we're going to basically do four questions more, and then that's probably going to do us. So let's see how we go for time, okay? So what's the probability that a child gets greater than a 78% on the test where the class average is 68 with a standard deviation of 8? I hope you guys can see that. I might make it a bit bigger. Okay. All right. So, bit of a odd bell curve, but we will stick with it. So, a lot of the questions, class average is 65. Now, standard deviation of 8. This next bit is going to be a 73, right? And this next one's going to be 81. And 78 is not one of those solid standard deviations that we can definitely get those percentages on the bell curve with, like here on the right. So 78 is actually somewhere here. And it's asking, what's the probability that someone gets greater? So it's asking for this area under here. Now, how do we do that? And this is where the calculator work comes into it. So this is not, this won't be on your first exam. The questions above that I've just done, they might be on the exam one, but this is where we need the the calculator, okay? So. This is where we're going to use a normal, it's called norm CDF function. Now, again, my calculator, it's different to the TI Inspire, but it does the exact same thing. The reason I like this one is if we go norm CDF, which is in, interactive, distribution, continuous, norm CDF. This actually tells me what each of those are, and it's kind of thing I like about this compared to the TI Inspire, where it just kind of like you just have to know. So the lower boundary we're looking for. So that's that there. That point right there, which we know is 78. That's what the question said. 78. The upper boundary. Now, is there an upper boundary? No. We're going all the way to infinity. So we put infinity. What's our mean? Our mean is 65. Oh, sorry. What's our standard deviation? 8. What's our mean? 65. Okay. So that's what we get asked with the norm CDF. We get what's the lower boundary? What's the upper? What's the standard deviation? And what's the mean? Okay. So that's what we need to know. Hit enter. Multiply it by 100 if you want the percentages, but you should know 5.2081%. Okay? Hope that's okay. Now, in the exam next week, I will be putting in some normal distribution as well as binomial distribution questions, okay? Or probability, sorry. Binomial probability as well. So, yeah, you guys can look forward to that. So, that's norm CDF. So again. Oh, right, sorry. It wouldn't be 100. So again, you're spot on correct where it's in a test 100% is the maximum. But for all of these questions, we assume that there is no maximum. These questions aren't written that 100 is the very, very end. So let's have a look. It will be extremely close. So if I just swap this and I swap it for that up as 100 and I hit enter, the percentage is 5.2075%, right? But it's not. We need to go all the way up to infinity because there's always a chance that with the test, you make a very good point that with the test it's hard to do, but a lot of this normal distribution would be, for instance, I think I got a question later, but rotten fruit. So what's the chance that I get if I have an average of 20 rotten fruit a week and the standard deviation of 2, right? So the common numbers are going to be 20, 22, 24, 26, yada, yada, yada. But there's also a chance I'll get 500 rotten fruit. It's a tiny, minuscule probability, but it is there. So that's why we go all the way up to infinity, because we need to include every single value up there, okay? And that's what the bell curve is. So it's a very good point with the tests. Just know it's always to infinity, okay? But as I said, you're going to get a tiny change in your probability, and rounding both of the values, just it happens to be for this one, rounding both of these will give you 5.2808%. Okay? Oh, percent. Oh gosh. You know what I mean. And what's that there? Getting a bit scribbly. There we go. Correct. As long as there's yeah, exactly. So the tail, which is that area that we're looking at, or if there's no boundary on the upper side, it's always going to be infinity. Okay? So here we go with a bit of a question. So very similar. What's the probability that a child gets less than 71% on a test where the class average is 65%? It's same question, just different percentage, okay? Okay, so we've got, sorry, I was just thinking in my head, just making sure that the multiple choice was right. I'll mute for a sec. Okay, so let's think about this one a bit logically first, and then we'll use a calculator. Okay, so we did get a response. Let's have a look. Oh, spot on. Yeah, B. So it's the same bell curve, which is very go me for thinking about that. So this one we're looking at less than 71%, right? Now, 71 is here. Well, that's roughly there. We know that 50% is from middle backwards. Now, we also know that in between 61 and 73 is 34%. And this is kind of where we can get a bit smarter and quicker with this stuff if we forget our calculator, which hopefully you won't. But we know that it's going to be less than 84 because our area is this area here. 84 is from 73 all the way left, correct? So we know it's going to be very, very close to 84, and it is also 83.38. So with the norm CDF, the lower limit is negative infinity. Make sure you do that negative, which I'm assuming you did because you got the answer right. And 71. And the standard deviation is 8 and 65. Okay. That's not right. Something was wrong. Did I do something wrong? Hold up. I must have put that in incorrectly in the answers. Oh, well, okay. My bad, sorry. 865, have I put that in all right? Yeah, I have. Okay. Sorry about that, guys. But it is the closest, which is good. Lucky at least that. But yes, it is 77.33. Sorry about that. All right. Yeah, I wonder why that is. Okay. All right, we're going to keep going through that even though. All right, so now we're looking at, this question here. So it's a different kind of question. Above what score will 45% of students get? So again, I always say, oh great, perfect. So above what score will 45% of students get? So if we have a look at this and we say, okay, no matter, we're using the same question. So mu is 65 and standard deviation is 8. Okay. What score, above what score will 45% of students get? Now this is a different type of question, isn't it? Because that's 65 here. I mean, that's 73, yada, 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 etc., etc. I think I can remember last night what my issues with multiple choice were. But anyway, let's keep going. So 65 and up. That's 50%, right? So we know that 45% is going to be somewhere here. That we're looking for a value pretty close to 65. Okay? Definitely below 73. Okay? Because 45%. So we use what's called the inverse normal CDF. Okay? Function on the calculator. So we'll come back. Interactive. Distribution. Sorry, inverse. Normal CDF. Again, my calculator might be different. Now the tail setting. Which way do we want to look at the area? So above what score? Our area is going to be all here. Yeah? So the tail is going to the right. Important that we remember that. Probability. My calculator, you need to input it as 0.45. Your calculator might be just 45. Just make sure. Our standard deviation is 8. And our mu is 65. Okay? 66. So again, we need tail setting. We need area, standard deviation, and mean. Now, I have a feeling I might have used the same, I might make the same error in the next question on multiple choice, but we'll give it a go, okay? Because I think I might have used the wrong mean. I was just remembering. So let's give it a go anyway. But 66.005 is our number. That's that one there, which makes sense, doesn't it? Yeah? And that's what inverse normal CDF. It's if we have the area or the probability, we can work out what that value is. Okay? So let's have a look again. All right, let's have a look. Give this one a go. Hopefully it's correct. Oh wait, it's a completely different question. Okay. That's okay. Good me. Go me. And remembering drawing that bell curve is the best way of doing this one, of understanding and how to use the calculator and everything. I'll give you guys. Again, sorry, and I'll link the Polev. Sorry about that. I should have linked that before. One sec. I don't want to link a unit circle. Where is it? Here we go. In chat, just for any newcomers, go for it. Sorry, I'll give you a bit more time. All right. So, I forgot to. Okay. Anyway, yes, correct. Great work. So that one is spot on. Okay. So again, let's have a quick look at how we got it. Again, we draw a unit circle. Got trigonometry on my brain. Here we go. Bell curve. We know that the mean was 165. Standard deviation was, hang on a sec, 6. So that's going to be 171, right? And I asked for 62% are shorter than. So we know that 50% is here and 84% is from here down. So that's 84 and that's 50. So it's going to be somewhere in between these. So we draw something down here. We know it's going to be somewhere between 165 and 171, okay? Now there was only one value here, which is that one, which hopefully if you did it logically like that without a calculator, great work. We then want to do, I'll just show you how to do it on the calculator. Inverse normal CDF, left, probability. What did we say the probability was? I've already forgotten. I think it was 62. So 0.62. We're looking at the area for the left. This area here. So that's why our tail setting is left. Standard deviation. How am I? 6. I was going to say, how am I forgetting this? And our mean is 165. Okay. There we go. 166.832. Actually should be 833. Sorry for my bad rounding, guys. Alrighty. 2 more questions. Great work sticking with me. I know we're almost there. So this is a given that question. And that's A given that B. So just so everyone knows, the formula is probability of A intersection B over the probability of B. So what percentage of students B, that's not right. What is the percentage of the students, oh no, it is right, I take it back. I just can't read. What would the percentage of students be that score over 81%, given that the score of the students is greater than 73%? Okay, so have a think. Let's have a look. So this question, we want to be looking at 2 things. We need to work out the intersection first. So probability of A, we can say that is students scoring above 81, so greater than 81%. Okay. Probability of B is students that score above 73%. Okay. So if we then look at a scale, imagine a scale like this, all the way from 0 to 100. This is just to visualize given that. If I said the people that scored over 81, that would be here, this area here, right? What about people who scored that over 73? Oh, sorry, I should write 81 there. People that scored over 73. That would be this area here. Right? Their overlap, the intersection between them both, is this bit here. So we can say that the probability up top for the given that statement is the probability of a score over 81. That's the intersection. And the probability of B is greater than 73. I hope that makes sense. If it doesn't, give me a message. But that's basically, we're just looking at where the two values overlap, where the two areas overlap. And in this case, it overlaps when it's greater than 81. Okay? So I'm going to assume that it's all good. If it's not, shoot us a message. Okay. Again, we just draw a bell curve. I'm just going to move through this a bit quicker. And we still had a 65%. And that was 73. And that was 81. Oh, okay. Well, that's helpful. So 73 and 81. So let's work on the calculator, even though we could do this outside of the calculator. Was it 8 or 6? Sorry. I think it was 6. No, it's 8. Cool. I was right. All right. So we're basically looking at what is the probability of someone scoring over 81%. We look at our calculator and we go normal CDF. Lower, 81%. Upper, infinity. Standard deviation, 8. Mean, 65. There you go. 2.275%. Right? The probability of scoring over 73%. Do the exact same thing. Oh, sorry. That's meant to be 73. All the way to infinity. 15.86. 6% or so. And all we do is now we do the formula of the first one divided by the second one. Okay, I hope that's okay, guys. It is given that questions are a bit confusing and we've done a whole lot today, so if you can rewatch it at a later stage, we do those divided by each other, multiply it by 100 to get a percentage. That gives us 14.3388%. Okay, I hope that's all right. As a given that question here, if you want, give it a go. That'd be great. And let us know. Alrighty, we don't have any responses just yet, but yeah, okay. I think that's right. No, actually A for this one. Sorry, I shouldn't have said that. I think, yeah, it's a very, very similar question. I think it's the very similar to this, but let's have a look. It's good to get it wrong now. Better to get it wrong now than later on. So let's have a look. So given that 10 are rotten, so that's probability of B, probability of greater than 10. More than 20 get rotten. So it should actually say probability of more than 10. Okay, so again, those two overlap, and that's what the majority of these will overlap. So if this is the probability that 10 are rotten, that area there, more than 10 are rotten, sorry. This is the probability that more than 20 are rotten. The overlap is always that second bit. Probability greater than 20. Okay, and we just do the division with that. So again, I'll do it relatively quickly. So continuous, normal CDF, lower is 20, upper is infinity. Infinity, I've been talking a lot today. Average is 12, standard deviation is 6. 6, 12. Okay, that is 9.12%. Okay, and might just also, the music's finished. So let's just put that one back. Hope you guys can hear it. I'll link the music in a sec as well, just because it's been some pretty good music. 0.06%. Okay, and then we just do them divided by each other. So 9.12 divided by 63.06, 14.46%. Okay, I hope that made sense, guys. Now, very last question, and then we're all done for today. It's almost been 2 hours. Wow. So, I'll make this one a bit bigger. So, this one's a bit more tricky because we are not told the standard deviation. Okay? So we know that the mean is 82%, and 43% of people score below 81%. Oh, it's all good coughing. Don't stress. Again, that's why we're doing this. So we know that 50% is from here downwards. That's 50%. Okay? So we know 43% is going to be somewhere, I don't know, somewhere around there. It's not going to be this far. So it's going to be between first and second standard deviation. Okay? And that's going to be our 81. Okay? So we need to work out what the standard deviation is. All right? And that's what this problem is going to be doing. Okay? To do this, we have to use something called the standard scores. Now, I hope you guys know the standard scores. It's just a bell curve. It's the most simple bell curve that you learn right at the start, where the mean is at 0 and standard deviation is at 1. So it's quite simple. 1, 2, 3, and again, those percentages are still the same. Of 34, 13.5, etc., etc. So to do this, we know the area, don't we? We know this, I'll make it green. We know this area. All the way up to that 81% that we're trying to find. That's 43%. Okay? So what we can do is we can have a look on the standard score, which, by the way, the formula to get a standard score, x minus mu over standard deviation. You'll need it later. You should know it. Hopefully it's on the formula sheets on the exams. Where was I? Yep. Okay. So basically what we want to do is transplant this area onto this graph. We transplant it here. All the way up here. Okay. Sorry for my bad area there. But basically we want to do our inverse normal CDF, but we want to do it on the standard graph, standard score. So we go interactive, distribution, inverse normal CDF. The tail's on the left, right? Probability is 0.43, 43%. Standard deviation, only 1. Mu, again, it's 0 because we're looking at the standard score graph. Gives us the point, that's saying this point here is negative 0.1764. Okay, rounded. Does that make sense? I hope that makes sense. And it's just basically saying this point here is negative 0.1764. Okay, Great. I'll take kinda. So then we basically, all we do is we use this equation here, because now we know everything. Z is negative 0.1764. Our X value, there, is 81. Our mu, 82. And our standard deviation, that's what we're trying to find. So we do a bit of rearranging. Hope you guys remember your algebra. Sigma, or standard deviation, equals 81 over 82. 81 minus 82 over negative 0.1764. And all we do is we put that on our calculator. There we go. Our standard deviation is 5.6689. All right. That's it, guys. That's the methods stream, revision stream. I hope it was helpful. Has anyone got any questions or want to chat about anything or anything? I'll open the chat up now. Yes, sorry about that. It was a lot. So I've done the further exam stream twice now, and I did 4 different topics on the further exam, and I just forgot how big trigonometric functions is. So as I was writing down the notes last night, I kind of just assumed that they would be, I knew methods would be longer. I didn't know methods would be that long. So apologies guys for the wall of information. Again, that video is up to, if you want to review it again. It'll be on YouTube as well as the Twitch stream. And do I do just methods and further? At the moment, yes. If there is a demand, happy to do biology myself and physics myself, but I'll be able to have a chat to some other tutors and see if they can run some ones for like any other subjects. So if there's other subjects you want to see, yeah, definitely. Yeah, so exam will be up next week, probably late next week. Please join, like the Facebook page, subscribe to follow the Twitch. I'll link both of those. Give me a second. So Test Me Tutoring. That's the website, obviously, if you to find the exams at a later stage if you want. And this is the Facebook page that I'll link now. Chuck us a like, where all the updates will come from there. All updates will come from there for updates on streams, updates on exams. I'm considering doing a stream just to go over different exam tips, how to study better, how to, for instance, the music I'm listening to, if anyone's interested. It's just a really good beat music. It's called lo-fi music. So that's the link for the music. Yeah, sure. So you can go to the contact form on the website, or just shoot us an email at testmetutoring@outlook.com. All right. So I know there's a whole bunch of links there, but also if you guys can, this is probably the one that is definitely not most important, because they're all important, but there's just some feedback. So that it would be great if I get from you guys. So I'll just I'll give you a link. If you can just fill out this Google Forms if you have a chance. Just on ways I can improve the stream, as well as if you've done the exam. And I'll be hanging around for another 10 or so minutes. Please, if you got any questions, anyone in chat, feel free to shoot them through. Happy to talk about uni, happy to talk about decisions in high school, anything to do with methods or further I can go through. Or you can shoot us an email to ask us the questions. Thanks, guys. So yeah, I'll just be watching chat and talking if anyone messages. Thanks. No worries. Hopefully it was beneficial. Thanks. Appreciate the feedback. Alright, let's have a look. Yeah, so that's what I found with some of my students as well. The online learning has really been difficult. So, yeah, it's a tough time for everyone. I think it's particularly going through year 12 at this point. It is quite difficult, and I really feel for you guys, and that's why I'm basically doing these exams, because I think some revision's always helpful, and it's really easy to get distracted, especially when it's Monday at 9 a.m. and you've got a double period of maths. Very easily just go to sleep. So I struggled when it was going into actual school, but when you're talking about online learning where there's you got to push yourself. But the good thing is that this will help for next year for you guys when you head to uni. You really need to have that drive, and I feel like this year it's been tough for year 12s, and it's going to help you guys when you go into uni, which is really good. It's one good thing coming out of this year at least. Yeah, so teachers, they've got it, admittedly they do have it pretty tough. They've got to swap to this online learning and swap out of online learning and back to online learning all within months, and it's difficult for everyone. So yeah, okay. So as I said earlier, I did mechanical engineering, and you need to love maths to be able to do engineering. It's one of the reasons I went into it. I really enjoy maths. It gets quite difficult, actually. If you're not at that, if you don't enjoy it, it's just a constant 4 years of just maths. Yes, there's some practical components and things like that, but I saw a few people get burnt out just because they couldn't deal with all the maths, honestly. So engineering, it's a fantastic course at RMIT. I learnt a lot. There might be some better unis out there, I'm not sure. I've only done RMIT, but I got a job through RMIT, through a couple of different companies. So it's worked out for me. And hopefully methods is definitely necessary to do engineering. If you don't have methods, I don't think you can do engineering in a lot of different schools. It's a prerequisite. So lucky you are doing methods, hopefully. So just to speak about the course at RMIT, if anyone is interested, it's a 4-year degree, but you get an honours with it as well, which is like kind of something that's necessary in today's day and age to be an engineer. But to be honest, if you do want to get into uni, which hopefully you all do, don't stress too much about that decision of what you do. If you go to something you enjoy and you maintain some decent marks, you can swap to literally any other course, no worries. It's much easier to swap course than to get into courses. My ATAR was 95.05. So I did methods and specialist. But as I was saying, thanks. The courses are very easy to swap between, so don't get too stressed about what you want to do. Especially engineering, there's you get 300 students, not kids, 300 students going in first year, and it's whittled down by a third by second year, just for people who swap into other courses. Plain and simple, people go into business, into commerce, into health, arts. There's so many different courses. So it's just getting into uni is the difficult bit at year 12, but I wouldn't stress too much. So if there's no more questions, we might end this stream there. I've done some further and some methods. Hopefully it's been beneficial to you guys, and anyone watching at a later stage, thanks for sticking around. Please join us on the live stream. Hopefully it helps. Appreciate it, guys. And yeah, look, please subscribe, please follow, chuck us a like on Facebook, and you keep updated. And look, the exams will stay free for a bit longer, so please utilize them, because I believe they'll be genuinely helpful for your exams. All right, see you guys.